Hello everyone and welcome to the Game Engine programming series where we write a game engine from scratch. Today I would like to start with a different topic than the one we have been working on for quite a while now, which was the scripting system. And that's opening a main window for our games and also being able to open multiple windows for use in the level editor. Before we start, I'd like to fix a couple of issues that were brought to my attention by one of my viewers. Thank you for that. First, there is a problem in entity_is_alive function that we have here. The point of this function is, of course, to see if our entity is still alive. And the condition for that is that the generations should agree. So the generation of the slot where the entity is in should be the same as the generation of the ID that we are receiving to check against each other. And of course, the entity has to have a transform component that's valid as well. So that's all good, but we have also this assertion that if the generations are not the same, then the program will crash in debug build. But of course, the whole point of this function is to compare the generations, so this assertion is not needed. The second issue that was actually reported in the GitHub repository for Primal Game Engine, and in issues, we can see that there is one issue. And here in free IDs, I'm using pop back, which should obviously be pop front. And I have got an interesting root cause analysis here that exactly states what happened and why this happened. And yeah, that's of course because I used a vector instead of a deck. And when I was intending to type pop front, it auto-completed to pop back, and I didn't pay enough attention to see that was the problem. So now I'm going to fix that. Here, first, we need to change the type of free IDs to deck. And then we can use pop front for this. And I, of course, need to change this to fixed. All right, so that's that. Thanks again for pointing those issues out. I'm always happy to hear more from my viewers how to improve and fix the code. So next, I'm going to add a new folder that will hold the platform-specific code for us. And in here, I'm going to add a header file that's for our windows. So this window header doesn't have anything to do with the Windows operating system. It's just a class that's a window. And that's actually basically the same as we did for entities and their components. So we just have a window ID and we encapsulate everything else in the CPP file that belongs to this class. So here I just create a new class for window. And I can basically just copy paste from this. I would like to use that macro that we have to generate typed IDs for us, but the header file that includes IDs and that macro is here in components. So I'd like to move this up a little in common header so I can use the ID header in other parts of the engine as well. I can go ahead here and use that macro to generate a window ID for me. And then I'll have like a generic interface here that we can use to, for example, ask for the size of the window and set its caption and go to full screen and those kind of things. So this is kind of a platform-independent class that we can use to represent a window. Next, we need a couple of functions that we can call to create a window for us and to remove the window from the engine if we close the window. Here in platform, we will have two functions, create window and remove window. And to create a window, we need some information to determine what kind of window we want to have. And for that, we need a window initialization information, just like the one that we needed for creating an entity, like this. But because we are not having a specific platform here, we just forward declare this and we don't know what it is yet. And I want to be able to create a window anyway, even if we don't give any information about the window. So if this pointer is a null pointer, even then we will be able to open a new window. And this function will remove the window from the engine that has this ID. So the reason that I would like to have multiple windows is so that we can have different windows in the level editor that we can open to view different objects in the renderer. So for example, we can have a model viewer and have a couple of those model viewers open to display different objects in the game and have a main renderer view that would show the game scene, right? So those are all windows that we can open here. But the actual game has one window because most games only have one window, right? Except when you have a device, a console like a Nintendo Switch that has an extra window somewhere on the controller itself. So then we would want to have multiple windows open in the standalone game. But most of the time, one window would suffice. Next, let's implement these functions. So here we'll have the platform-specific implementation. And for each platform, we can implement it in an if-def block. So for example, for Windows, we can implement creating and removing windows here. So let's start by implementing the create function. Now here we have to know what this window init info actually is. And for that, I'm going to add another header file that will contain the platform specific data types. So here, finally, we include the Windows header because we are now in platform-specific scope. Here I define two data types, the window proc, which is just a function pointer with this signature, and that's the window procedure that will be called back whenever we receive messages. So here, for example, in the main CPP, you can see that we receive messages here and dispatch them. And when we dispatch messages, some of those will be processed by the window procedure that is called whenever this message pump is run. And we'll have a window handle type, which is just a window handle. And here I can define what this window init info is for the Windows operating system. So if we are going to use Windows operating system to open Windows, then we need this information to open it, but it's optional, so we don't really need this per se. And this parent is needed for when we want to open a window for use with the level editor. And then we can now continue here in create window. We can include that platform types header. So if we have this pointer and it's not null, then we can use the information in it. So we can, for example, use the callback function pointer, but it also might be a null pointer anyway, so it's still optional. So in the Windows operating system, when we want to open a window, we have to do three things. First, we need to set up a window class. Then we need to register that window class. And finally, we create an instance of that window class. So what I'm going to do has been done a million times before, so I'm not going into a lot of details, but I'll just explain what I'm doing. First, we need to fill in a structure that's called window class X. And this is basically this structure that we need to fill in. This one is the size of the structure, so it's just the size of window class X. This is the style of the window, and the style that I'm going to use is the window that's going to be repainted every time the width or the height of the window is changed. So horizontal redraw and vertical redraw. And these are art together, so both of these options are enabled. Here we need a function pointer to an internal window procedure. So let's see what this looks like. Remember the signature of this callback that we have here. It's the same basically. So here I can write a new function. And then I'll implement this in a minute, but first let's carry on filling this structure in further. This CLS extra is going to be null. So this CLS extra is a number of extra bytes that is allocated following the class structure. But we don't need any extra bytes allocated, so that one is going to be 0. But we do need the window extra pointer, and that's if we have a callback function that we can ask the window about. So if we have this extra room to put this pointer in it, then we can retrieve that pointer in this internal window proc to call that function. And the way we can do that is to go here and then call a function that's called getWindowLongPointer. So this long pointer is pointing to a buffer, and at this index, we reserve these extra bytes to put this callback in. So we can get those bytes again and then convert them to the function pointer that's the callback and then call that function. So here we get a pointer to that callback function, and if the pointer is not null, then we can call it with the parameters that we get here. And if it is null, then we call the default window procedure with the same parameters. This one can be 0. For now, we'll load a default icon for Windows applications. And the default mouse cursor, which is just an arrow. And we can also set a nice background color. We don't have a menu, so that one can be null. And the class name is primal window. And this one is a small icon, and I'm going to use the same as the icon for the application. And that kind of concludes filling in this window class X structure. Next, we need to register this class. And this function, which is actually a macro, will return an error if the window fails to register, which can happen if we try to register the same window class multiple times, which we will do because we are going to open the same window multiple times, basically, and this function will fail after the first time. But that doesn't matter because if it fails, there is no problem. The window is registered anyway, and we don't check if this function fails. As long as it doesn't fail the first time, that would be bad. The next thing we do is to create an instance of the window class. And that we can do by calling createWindowX. So this createWindowX has got a lot of parameters that we can look up now. So the first parameter is the extended style, and we are not going to use that. So this one can be null. The next one is the class name, which is here. So I can use this member of the window class. And this one is the window name, which we can have here. For example, this caption is the window name. So because all those members in init.info are optional, we can check here if that contains any information for caption, and if not, we can add our own. So we are going to use Unicode characters for the caption. That's why I changed this char to wchar-t. So if we have this information, we can just take the caption, and otherwise we'll just use primal game as a default caption for our windows. Next is the style. Before we do that, I'm going to define a new structure that we can use to hold information about our windows. We of course have this information here that contains the window ID, but the data itself about the window is of course platform dependent, and that's why I'm going to define a new structure here. So when we create a new window, the information about that window is contained in this structure, and we save this in an array so that later we can refer to this by using this ID. So before creating this window, I'm going to have an instance of that window information. So to define a client area, which is the content of the window except the title bar and the edges, we need to call a function that's adjust windows rectangle, and that will fill in this rectangle for us, and it will do that with respect to the window style. So if you have a style with thicker edges and title bar, or a style without those, then we will have obviously different rectangles. And this function will take care of that for us. So here for the style, I can use the style that's defined in this information structure. And then we need to have a position for our window, and that information is also in this init info, or could be in there. We have to check first. So if there is an init info pointer with a left position, then we can take that, and otherwise we'll just use the client area's left. And we do the same thing for top. Next is the width and height of the window, and that's also in this init info. So we again do the same. So if that information is present, we take it, and otherwise we can calculate our own width and height by just subtracting the right and left and bottom and top of this client area rectangle. And here for the parent, we just use this parent that we defined here. So it could as well be null, but it doesn't matter if it is null. And we have no menu, and this instance can be null. And we have no extra parameters. Alright, and now I can get rid of all of this. And we of course need to remember the handle to this window, which goes into info handle, window handle. And we also define a style for our window. It depends whether we have a parent or not. If we have a parent, that means that we are using it with the level editor, and therefore we need to set it as a child window, and otherwise it's not a child window. And that's all we have to do to create a window. And now, if we succeeded, we need to save all the data that we have here. In the next video, we are going to add information about the windows that we create this way to a list. And also we are going to write a test program to display our windows. Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus, there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering!